Yeah, what's up guys? Welcome back to Maths with Gaston. Here is paper 2 of June exam 2025. Let's have a look at question 1. Right, so for those of you have watched paper 1, I'm sure. That's why you're here now to continue with paper 2. Let's see how you would have gone in answering the following questions. We are given a triangle right there. As you can see, the triangle it's given right here. We have got here angle of inclination. Some of you have indicated that sometimes I move a little bit fast, so I'm going to try by all means to explain as I move along some of the concepts, and then just to remind you guys. Right, so now let's have a look at this one here. We are given here A, B and C. They've given us all the coordinates, which is really good. And then they are saying here 1.1 here, it says calculate the length of A B, right? So we're just gonna come here straightforward. Here we use the distance formula to calculate the length of AB. AB is going to be given by square root of, on our distance formula we're going to say x of A minus x at B. Sometimes you can use numbers guys, it really doesn't matter, it's still fine as long as you know which one is your y1 and which one is your y2. Really doesn't matter. But here my learner suggested that we use the letters of the coordinates that we are dealing with, so that it's easy for one not to make a mistake. Right, so x at A, it is given by minus 3, then x at B minus 4 all is squared, plus y at A it's minus 1 minus 6, okay, all squared. Punch that into our calculator. We're going to get that AB it's given by 7 square root of 2 units. I just put units here guys. If they didn't give you the units, if they gave you the units, please you need to put them down there. All right, and that's how it is. Straightforward distance formula. 1.2 said find the coordinates of D, which is the midpoint of AB. So which is D here is the midpoint of AB. We need to find that coordinate, so we're just gonna come here and apply the midpoint formula guys. So midpoint of AB, which is D, right, is going to be equals to x at A plus x at B all over 2 y at A plus y at B all over 2. Straight point, midpoint formula, straightforward guys. And then there shouldn't be any confusion here. You are just applying the formula. If you're not following, please let me know on the comment section below. So it's going to be minus plus 4 all over 2, and then y at A is negative 1 plus 6 all over 2. So this one here goes ahead and gives us half all over this is going to be 5 over 2. So this gives us the coordinates of D, right, which is the midpoint of AB. Right, okay. 1.3, no trick as yet guys, just a straightforward formula. And then they said calculate the angle of inclination of a line AB, which is this one right here. Remember, angle of inclination, the definition says this is the angle that the line makes with the x-axis, right? So by definition, how do we get that? We get that by saying angle of inclination, which in this case will be alpha, is equal to tan the gradient of the line we're referring to. Okay, so gradient of AB. Okay, so now we don't have the gradient of AB, so let's start by finding out the gradient of AB using the formula. Gradient of AB is going to be equals to y at A minus y B. Remember guys, if here you use y2 and y1 is still fine, x2 and x1 is still okay, no problem with that, as long as you substitute what you need to substitute where you have to substitute it. That shouldn't be a problem. All right, y at A is negative 1 and then minus 6 all over x at A is -4, then minus 4. Great stuff. So now here, what do we have? We're going to have, here is going to give us -7. Am I right? Yes, -7, and here at the bottom -7. So our gradient is equals to 1. The gradient of AB is equals to 1. So now we're gonna come here. I'm gonna continue up here, guys. We're going to come here and say alpha is equals to tan. Remember now, no, it's not like this, man. Why I got the definition wrong? It's not like that, guys. I'm gonna remove it. So here, right here, it's wrong. It's going to be, it says what? Tan alpha is equals to the gradient. So here, as I stated it wrong here, guys. This is completely wrong, right? So now we know the gradient here, the gradient that side. So it's going to be tan alpha is equals to 1. So therefore you're gonna come into your calculator, you're gonna say shift second function 1 should give us the answer, and then the answer is equals to 45 degrees. Okay, so that is our angle right there. Okay, great stuff. So moving right along to 1.4. 1.4 says calculate the angle of inclination B of the line BC. So now similarly, this is what we do. 1.4, similarly, you would say beta, would say that by definition is going to be tan beta is equals to the gradient of BC. So now we need to find the gradient of BC first before we can do this. So y at B minus y at C all over x at B minus x at C. See how I'm making this thing very simple, guys. No confusion. I just take the formula, then I apply it. All right, then the rest will be algebra. So let's go there and see the coordinates. Y at B, it's 6, and then y there is going to be minus into -2, which is the y at C. We can see is 2 there. All right, then x is going to be 4 minus 6. Okay, there you go. And then it's going to be what? It's going to be 8 all over -2, which is equals to the answer now is -4. Great. So the gradient is equals to -4. Right. So now when you come here, guys, you're gonna go ahead and say tan beta is equals to -4. Right. So now here, this is where the trick is, because when it's negative, when you say negative, is going to give you this angle right here, guys, the other angle, and you are looking for this one here. Right. So now what we do, we say second function, but we don't include the negative in this case. Okay, so this one will give us the reference angle of beta, and then when we say 4 in my calculator, it is giving me a reference angle of 7.5.96. Okay, let me just double check something here, guys. Okay, do we put a negative or we don't put a negative? Oh, you know, guys, doing this thing without a calculator. Wow. All right, so now that's my reference angle. So now we need to check where is tan negative. Tan, it's negative at a second quadrant, where it means now is going to be what? 180 minus that reference angle that we got. Because I can see, I saw on the, when we're marking, they do give a mark for the reference angle, guys. So I don't want you to skip this part, because you might lose some marks. Okay, so now it means here our answer here is going to be 104.03 degrees. I just confirmed this one, it's fine, it's 7.5. Then you remove it from the second quadrant where tan is negative, né? Right. So now this gives you this angle right here. The reference angle gave you this one here, which was 75. So now the other angle, which is beta, now it's 104.9, 0.03 rather. Okay, so now let's move on to 1.5. So 1.5, I will have to now move to the next All right, 1.5, I think we can just do it here because we've got all the numbers here that we need. So 1.5, guys, if you still remember, this is what? This is 45. Okay, then you've got a 75 here. If you have a look at this triangle, they're asking you to find this angle right here, which is angle B. So now if you look at this one, this triangle starting from here, going there, and then there, and then there, right, with the x-axis. So basically this gives you something like this, ladies and gentlemen, gives you something like this. You've got a 75 there, you've got a 45 there. Then you're looking for B, which is this one here, which is simple sum of angles in a triangle, and then it will give you this one, right? So now we can just simply go ahead and find this one here. We can just say, okay, angle B is equals to sum of angles in a triangle minus alpha, then minus that 75 here, which is initially it was what? The reference angle, which is 75, the reference angle of beta. So I can just put it like this here. I can say there's many ways to do this one, guys. Please let me know. There's other ways. Please let me know on the comment section below. I know there's a lot of ways. You might not have done it like this, but guys, what matters is if you must get it right. Okay, so now this will give us an answer of 59.03. okay, so this is our angle B, right? Okay, so now you might have said, okay, no, what if now you worked the other way around? I think I'm gonna just explain this here, right here. Okay, what if you worked the other way around? You said, okay, no, I have got this angle here, which is beta, which is this one here. It was 104. Okay, now you can say you have got this as an exterior angle of this triangle that we highlighted here. So if this is an exterior angle right here, guys, is your exterior angle, the one I'm shading here, what does it say? It says that exterior angle of a triangle is the sum of the internal opposites. Okay, so you can still get it right in that way. Do it like that. Let me know in the comment section below if you got it right. If not, drop a comment, then I will do it the other way around just to illustrate what I'm talking about. But if you are aware of the concept, then you should know how to deal with it. Just me, I chose to do it the other way around, but you can also do the other way around as well, and let's see if we're gonna get the same answers. If you like this video, give it a huge thumbs up. If you haven't subscribed, please guys, I'm kindly asking you to subscribe so that YouTube can give us something, so that at least on the adverts we can get something or two, then we can continue to doing more videos for you. Or please just like the video. I'm kindly asking you to just subscribe to our channel. Let's move on to 1.6. 1.6 says here, determine the equation of a line passing through AB. Line passing through AB. Okay, so this is the equation of a line passing through. So this line is like that. Okay, they didn't say to us line passing through AB. Okay, line passing through AB. No, they didn't say it's perpendicular. They just said this line is passing through line AB. So okay, right, so it means this is the equation of this line here, AB, right? So now we need to find that. I think we already have the gradient. Equation of a line can either be written like this. We can choose a coordinate B here, gradient of the line that they are referring to in this case, which is AB, and then you can say x minus x at B, right? So we know the gradient here, we calculated it initially. The gradient was 1, so the y here it's 6 is equal to 1, and then x minus x, which is 4, y it's equal to, times everything by 1 here, it will remain the same. It's just going to be x minus 4, then you bring 6 to the other side, is going to be positive 6 here. Okay, so now I'm just going to have y is equal to x plus 2 is our equation of the line AB. Okay, Please let me know what you guys think. That was question number 1. If you click here on the link that is appearing now on the top on the bottom right corner, you will see it's a list. It will take you to question 2, 3, 4, 5 and the rest of the paper. I am Gastin Mapala. If you haven't subscribed, I'm kindly asking you to subscribe to our channel. We are on the road to reaching 10,000 subscribers. I'll see you on question 2. Okay guys, so here is question 2 right here. Thanks for tuning in right here to Maths with Gastin as we continue with this paper from Limpopo province of June 2025, grade 11. It says here on this question that A and B, it's a parallelogram with a vertical, with a vertices rather. Hey, so vertices A, B and C. D is not given. All right, so C, they said here it's -2. I'm just gonna put it here because I think it's not visible there. All right, so now we already see that they put it on a Cartesian plane where we can tell that here it's on the second quadrant, here is on the third quadrant. So 2.1 says here determine the length of AC. So 2.1, we're just gonna go ahead and apply the distance formula here. AC is equals to square root x at A minus x at C all squared plus y at A minus y at C all squared. Right, so now it's equals to, so we're just gonna substitute everything here into our, okay, let's see which one is A. A is here, okay, A, B, C, D. Right, so it's going to be -4 and therefore minus they said what, distance AC. Okay, so it's going to be -0 here all squared plus 6 minus into -2 all over the bracket squared. So when we punch this into our calculator, straight away I'm getting 4 square root of 5. Okay, so yeah guys, if you were to continue in this one and say it's equals to, you are getting 80 here, you're just wasting your time guys. There's no marks for this part. If from here we're just gonna mark you for the formula, then mark you for substitution and the answer as well, right? So yeah, so you can just go straight to the answer from there off, right? So 2.2 says determine E. Okay, E says is the midpoint of AC, so E is sitting somewhere here, midpoint of AC. Okay, so we're just gonna come here, say 2.2, then we apply the midpoint formula, midpoint of AC. We're just gonna come here, said x at A. All right, x at A plus x at C all over 2, and then y at A plus y at C all over 2. This is the midpoint formula guys. So straight away you're just gonna come here and substitute. So x at A -4, okay, plus 0 all over 2. Therefore here y is 6, okay, plus, therefore plus -2 all over 2. Okay, all close bracket. Now as you can see here, we're going to have minus, the answer here is going to be -2, and then here you're going to have minus, it's going to have 4 divided by 2, it's going to be +2. So this gives us the coordinate of E, which is the midpoint of AC. So the coordinate here will be -2 is to 2, which makes sense because we're on the second quadrant. A is negative and Y is positive. This is also another way that you can check that your answer is correct. If you just tuned in right here, we are busy with this question paper. We are on question 2. This is what you're watching currently now. I am Gastin Mapala, specializing solely on mathematics from grade 10 up until grade 11. All the lessons are here, or all the chapters, and all paper 1 and paper 2. If you haven't subscribed, kindly subscribe to our channel. We are on the road to reaching 10k subscribers. Right. Okay, so let's move on. 2.3 says determine the coordinates of D. So D is this one sitting here, because they said this is a parallelogram, ladies and gentlemen. So it means here that the diagonals, they bisect each other. Okay, if you recall, the properties of a parallelogram means what? The diagonals, they bisect each other. So this midpoint here of AC, it is also the midpoint of AB. So that simply means we can use the midpoint in reverse to find the coordinates of D. So it means D, okay, which is our coordinate here, is going to be the X. Going to have what? We're going to put here the X coordinate of B minus the X coordinate of D. Okay, no, rather E here, which is our midpoint. Okay, and then that of D all over 2. And then similar thing, we'll do the similar thing for Y. E at Y is going to be equal to the Y at B minus the Y at D. No, is it minus or is plus? Oh guys, oh, what a terrible mistake. It's a plus here because we're dealing with the midpoint here. Thank you very much for that correction, guys. I was about to make a serious blunder there. Okay, so now with that, now we know the coordinate of E at X is minus 2. It's equals to the X at B is 3. The X at D, we don't know. This is what we're looking for. Divide by 2. So what we're gonna do now, it's over 1 here. We cross multiply. So this is what we're gonna have 3 plus X at D. It's equals to 2 times negative 2 is equals to negative 4. Then you take 3 to that side. So X at D is equals to negative 4, negative 3, which gives us X at D as negative 7. Excuse me, negative 7. So a similar thing would apply here. We come here, we say our midpoint is what? Is 2. Is equals to Y at B. Y at B, it's 5. We don't know the Y at D. All over 2. So we're going to have 5 plus, we're doing cross multiplication here, guys. We cross multiply each other, this 2 times that, and then this over 1, cross multiply, so it's equals to 4. Then we take the 5 to that side. Y at D is equals to 4 minus 5, which gives us Y D is equals to negative 1. So therefore we can tell the examiner that the coordinates at D is what? Negative 5 and negative 7 rather, and negative 1. And then that should be it. Great stuff. All right, so now they come here and then they say to us 2.4, they said calculate the equation of a straight line drawn from B but perpendicular to AC. Straight line drawn from B perpendicular to AC. Straight line from B perpendicular to line AC. So we are drawing this straight line right here. Okay, perpendicular to AC. Right, so now this is what you would do here for 2.4. You're gonna find the gradient of AC, because the equation would say this is our formula. Or you can do it the other way around, guys. But for me, I prefer doing this way because it makes life very easy, and then you don't have to worry about finding the C value and whatnot. But do the method that you're comfortable with, as long as at the end of the day we get the right answer. Right. So we're gonna have the Y at B. Mine is equal to the gradient of the gradient that, remember, this is the gradient that is perpendicular to AC. It's not actually the gradient of AC. Right. X minus X at B. So now let's go ahead and look for the gradient of AC, then look for the one that is perpendicular to that. You would know the relationship between two gradients that are perpendicular to each other is that the product of those two gradients that are perpendicular, they need to give us negative 1. So let's come here, start by finding the gradient of AC. Okay, I'm just gonna let's just apply the formula here, guys. I think we've done this in question 1, so it should be easy for us here, and then easy for you guys to follow as well. So y at a is negative, no it's not, it's 6 minus into minus 2 all close all over negative 4 minus 0. All right, there on top we're going to have 8 all over negative 4, which gives us a gradient of negative 2. This is the gradient of AC. So therefore now with this, so the gradient that is perpendicular to this one, that will give us an answer. So gradient perpendicular to AC is equal to 1 over 2. Right, so now we're gonna continue with this gradient of 1 over 2. So now we're gonna substitute there into our equation. Remember the coordinates B, they are given by 3 and 5. Okay, so please guys, kindly like this video to help YouTube to push the algorithm and also to motivate us to do more videos for you guys. All right, so minus y at b, it's 5, it's equals to the perpendicular gradient, which is half x minus 3. So therefore with that said, let's go calculate by multiply everything by half here. I'm removing the bracket here, guys, right, and then negative 3 over 2, and then take the 5 to the other side, which gives us positive 5 here. Then the only thing we need to do is to simplify the fraction there, and then which gives me a value of plus 7 over 2, and therefore this is the equation of a line that is perpendicular to AC. My name is Gaston Mapala, right here at Maths with Gaston. Let me see you on the next one, where we'll be doing question 3. If you haven't subscribed, please consider subscribing as we're pushing on our road to 10k subscribers. I love you guys. All right, guys, here is question 3. It's on trigonometry. As we continue with this paper, I am Gaston Mapala. Thanks for tuning in. If you haven't subscribed, please consider subscribing. So let's have a look at this one. It's question 3.1. 3.1 said if 2 tan theta minus the square root of 3 is equals to that, and it's between theta is greater than 180 but less than 360. With an aid of a diagram, they're asking us to find sine squared theta plus cos squared theta, right? So you're just gonna come here and say, okay, no, 3.1, we understand them what they're saying there, but they're giving it to us in terms of like this. So this is the tricky part, guys, but if you know how to deal with this, make life easy for yourself, is equals to 0. So you need to solve everything and leave tan theta in the left hand side. So we're gonna take a negative square root of 3 to that side. So we're gonna have tan. Before you can start, guys, you're gonna have square root of 3 here. Then we're gonna divide by 2 all the sides. So we're gonna have tan theta is equals to square root of 3 divided by 2. And then we know, guys, from SOHCAHTOA, it says that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and then tan is opposite over adjacent. SOHCAHTOA. Right, so now let's come here and see on which quadrant are we going to be. So we all know that this is 90, this is 180, then 360 somewhere there. This is no, this is 0, this is 90, 180 is here, and then this is 360 as well, then 270 somewhere here. Okay, so now they're saying is theta is greater than 180, so it's here. It's bigger than 180 but less than 360. So you can just tell where tan is positive, so it means it's on the third quadrant. So we know here tan is equals to opposite. Opposite is going to be here, so theta will be there. Opposite over what? Over hypotenuse. Okay, no, opposite over adjacent. So adjacent, it's somewhere here. Okay, opposite over adjacent. So adjacent is what? Is going to be 2. But we know that on the third quadrant here, it's negative, x is negative, and also y is negative. So we are going to look for the hypotenuse thereof. Right. So now looking for the hypotenuse, we know that it's going to be x squared plus y squared is equals to r squared. We apply Pythagoras theorem. We're going to substitute which one is x, which one is y. Opposite is y. So this is y over x there. So it's going to be square root of 3 all squared. No. This is going to be negative 2. X is negative 2. Sorry about that, guys. X is negative 2 plus y. I'm writing what I'm saying. Y, it's a negative square root of 3 all squared is equals to r squared. So now we're going to solve this on the Pythagoras theorem. Is going to give us r is equals to square root of that is 4 plus 3, which gives us square root of 7. So r is equals to square root of 7 right here. So now what are they saying? They are saying we must find sine squared, theta, and so forth. So it's with 4 marks. So now we're going to come here and say sine squared theta plus cos squared theta. So now with this in mind, sine is equals to what? Opposite over hypotenuse. So it's going to be what? It's going to be negative square root of 3 divided by square root of 7, which is hypotenuse all squared, plus cos, which is adjacent, which is negative 2 all over square root of 7. Please guys, you need to show the negative. If you don't show the negatives here, they are going to mark you wrong. Okay, so now with this, we can go straight into our calculator to find out how much does this fraction give us here. This fraction will give us 3 all over 7, plus here is going to give us 2 squared, which is 4 all over 7. Then our answer is going to be 7 over 7, which is basically 1. Right, great stuff. So it makes sense. I think you guys are following there. If you're not following, drop a comment. Let me know what you guys think. If you're enjoying the content, please like this video, share it with your friends, your classmates, your cousin, your brother, your sister, and everyone who really needs this video and they are busy with mathematics and they are finding it difficult to understand trigonometry. Okay, moving to 3.2. 3.2, they said if cos 20 is equals to p, determine the value of p. Determine the value of this, or okay, they want us to determine the value of cos 340. Okay, determine the value of if cos 20 is equals to p, they want us to find cos 340. Right, so now cos 340 can also be rewritten as cos 360 minus 20. Okay, this is what reduction angles. So if you can write it like this, we will say is cos positive or negative at 360 minus. 360 minus is on the fourth quadrant where cos is positive. So now it means now it is just going to be cos 20 in this case, which is basically equals to p. And with that, you get your 2 marks. Right. Okay, guys. I hope you guys are following. Let me know if you're not following. Let me know. But I'm pretty positive that we do have a lesson. But I'm gonna show you something before we go to 3.3, because 3.3 I think is going to require us to do, because it's all about reduction and simplifying. So, or rather, I will explain it when we get there. Right. So now let's go to 3.3, and then it says here 3.3, 3.1, 3.1.3.1. It's saying here they want us to do what? Simplify. So there you go. 1 minus cos theta close bracket 1 plus cos theta close bracket. So they want us to simplify this. So basically what we can do now, we can just start by removing the brackets, leave the square root as it is, because for now I think it will be confusing. 1 times 1 will give us 1 here, and then 1 times cos Cos is going to give us positive cos theta. Negative cos times 1 is going to be cos negative cos theta. Negative, and then it's going to give us negative cos times cos is going to give us cos squared theta, close bracket, everything under the square root. So here, as you can see, guys, when we simplify, this cos and this one would cancel out. The other one is positive, the other one is negative. So you are going to be simply left with 1 minus cos squared theta. So 1 minus cos squared theta, we know that in terms of the identity, guys, you remember this identity here of saying sine squared x plus cos squared x is equals to 1. So we can rewrite these as in terms of sine squared. So this can also be rewritten as sine squared theta, and then with the square root on it, our answer will just be sine theta. Right. Oh, okay. Oh yes. So just our answer will just going to be sine theta thereof. So let's move on. 3.3.2. 3.3.2 still is simplify. So now let's have a look at this one very carefully. It's sine x minus 360 degrees, and then sine 90 minus x, all in brackets, tan minus x, all over cos 90 plus x. Right. So now with this one, guys, I have got this diagram that I really like a lot. Is this one here that shows us when do we, this is a second quadrant, is called cast diagram. Sine is positive, so this is what on the second quadrant everything is 180 minus x. Here everything is 180 plus x. Here everything is what? It's minus x, and then a 360 minus x, and then you have got the 90, the plus, and the what. The most critical one, you just have to know that anything 90 minus x will change the sign and the cos, but the most important one is the one of cos 90 plus, because it changes to negative sign. So the NB one here, it's known cos 90 plus, it changes to negative sign x. So this is the most important one here. So guys, these things that I wrote here, you must know them by heart, because they are not anywhere else. If you don't know them, you are going to struggle with trigonometry. I suggest that you watch a video lesson on trigonometry, but these things must be on your head. I'm going to repeat it. If you don't know these things, these are basically the DNA of trigonometry, right? So let's come here and see. So everything else has to be a number minus x. So if it's like this, then you must take out the negative and shove them around. Okay, so let's come here and see. So we're gonna take out the negative right here and say sine 360. So it's like we remove the common factor of negative minus x. So here is what everything 90 minus x has to change. So this one will change into cos x. And then here it's a negative here. We know that here it is, here is on the fourth quadrant. So tan here will be negative times. So it's going to be negative tan x here. And therefore, close bracket. Remember, this is the dangerous one. They like this one, guys. Just know that it's going to change into sine x because it's 90 plus or minus. But however, this one has to be negative, right? So now, 360 minus is on which quadrant? Is on the fourth quadrant where cos is positive, so sine here will be negative. So it simply means here we're going to have another negative of sine. So it's going to be negative sine, okay, which is the one that we took out as a common factor. Remember that. So this one will also give us another negative sign, just to put it here so that you guys don't get confused. All right, so you're going to have cos x here, then you're going to have negative tan x. Excuse me. And then here we go, divided by negative sign x. So now when you simplify here on top here, what are you gonna have? You're gonna have sine x cos x. Then this tan is going to be negative sine x all over cos x. all divided by sine x, okay, which is negative by the way. So this cos and that cos would cancel out, and then this negative sign and then this negative sign would cancel out. Negative and negative would cancel out. Then your answer is just going to be left with sine x. It's our answer. Right. So that's how you deal with a question like this one. I am Gaston Mapala, right here at Maths with Gaston, dealing with mathematics, hoping that you understand. If you haven't subscribed, please consider subscribing. We are on the road to reach 10,000 subscribers. Right. So now let's see. Hence, now 3.3.3, they are saying hence, so they are saying continue from where you left off. Hence, determine the values of x for which between x is greater than 0 and less than 360 degrees. So basically they are saying find out if, so now we are just saying, okay, no, this sine x, so you know that this whole thing here, guys, after simplifying is just going to be sine x is equal to 0.5. So basically that's what they are asking you to do. So we're just gonna come here and find then we're gonna go here and say x is equal to second function shift 0.5, then it's just gonna give us an angle, which in this case I think is 30 degrees. And then also we know where is a sign positive again, is positive also on the second quadrant where we deal with 180 minus x. So it's just going to be minus 30, which gives us another value of x, which is 150. Therefore, you've got your two answers here. You should get your 2 full marks. Right. Okay, now that's trigonometry, which is a bit tricky. Trust me, guys, you need to follow trigonometry, because even in grade 12 you're going to find it, and then they are going to add more stuff in grade 4. So please make sure that you pay attention. If you don't understand, please ask in the comment section. I will do my best to answer all your questions and also to get back to you either by replying through a video, then I'll share the link with you to that video where I have replied to you, or not. Really doesn't matter. You don't have to pay anything. You just have to have data and watch the videos and subscribe, of course. Right, so let's move on to 3.3 or what? Yeah, 3.4. Great. 3.4 is an identity. It says here, prove that this 1 over cos x is equals to this on this side. Right, so 3.4 okay, but now here, ladies and gentlemen, we're gonna, if you look at the, normally we'd start at the left hand side with identity, but if you ever look at our left hand side, there isn't much to carry on from on that side. So let's just take it from the right hand side. So we're going to tell the examiner that us will start from the right hand side, where we have got cos theta all over 1 plus sine theta, therefore plus sine theta. I'm just going to break down this tan here, theta. So if we've got a fraction, guys, you know straight away they're saying we need to prove. So we're just going to have here, we're going to have our LCD, okay, which is given by that. Everything at the bottom gives us our lowest common denominator. So this cos here, this 1 plus sine here, it's like you're cancelling out, guys. I always say to Malenas in grade 12, like it's like you're cancelling out. So 1 plus sine, 1 plus sine, it will go 1 plus sine. Therefore, we're going to be left with cos. So it's going to be this cos from the LCD times this cos here on top. So cos that. So now you're going to say cos goes how many times here? Is going to go cos, cos and cos cancel out. You're going to have the sine here on top, multiply by what is left out on the LCD, which is 1 plus sine that. Right, great stuff. So you're going to multiply here, cos times cos is going to give us cos squared theta, and then plus here on top you're going to have sine theta times 1 is going to be sine theta, sine theta times sine theta. I'm removing the bracket here, guys. Binomial is going to be squared all over cos. I suggest the LCD you leave it as it is. Let's not remove anything here because it's already factored. At some point I'm expecting that we cancel out something with something here. All right, so you see here sine squared and cos squared gives us 1 according to the identities, ne? it gives us 1 plus sine theta all over cos squared 1 plus sine theta, right? So now with that, you can see that 1 plus sine theta is at the top and also at the bottom, so therefore we can cancel this one out. We're going to be left with 1 over cos theta, which is equal to the left hand side. Then we get our full form marks, guys. Just like that, you have done what is required, and then you are smiling out of that exam room, right? So now moving right along, let's move on. We're looking at now, let's move to 3.5. 3.5 says that from which values of theta interval 0 to 330 is the identity in 3.4 undefined. So here, guys, when they speak of undefined, basically what they are asking you for a situation where you would divide by 0. So basically they're just asking you where you would have an error. So you know, every time when you divide by 0, you are going to have an error. So what we do, we are going to say cos, which is our denominator, we make it equal to 0. This is the first one, and then also the second one, which is 1 plus sine theta, we make it equals to 0. Then we solve for theta. So theta is going to be equals to second function shift cos, I get 0 is going to give us how much? It's going to give us, I'm getting 90 here, guys. And then also the other one, we'll have to take 1 to the other side, is going to be sine theta is equals to -1. Then we go second function shift sine, second function -1 here. Is it -1? Okay, yeah, it's -1, but we don't put the -1. Yes, yeah, okay. Then we are going to have theta here is going to be 270. I know what you guys are gonna say. No, but I'm not getting 270. What not? Okay, the reason you're not getting 270, you have to, let's see. Let me just double check this thing on my calculator first. Guys, I'm Gaston Mapala right here at Maths with Gaston. If you haven't subscribed, please consider subscribing. We are on our road to reaching 130 subscribers. As I check this here, if you have to leave the negative out or not. Yes, you must leave the negative out, guys. If you leave the negative out, you're going to get 90. Okay, so now here, guys, if you put the negative here, you're going to get 90. So what you do, if there's a negative, I normally tell my learners, don't put the negative. So what you're gonna get, if you put here, you're gonna get 90. So this one becomes your reference. So where is sine negative? Sine is negative in the what? In the third quadrant, where you have got 180 plus that reference angle that we just found. So it means it's going to be what? 180 plus 90, which gives you 270. Be careful, guys, whenever there's a negative, you can't find a negative angle. Okay, it always means something else if there's a negative. So I suggest you remove the negative first, and then you found the reference angle. Therefore you can say where is sine negative, whether it's cos or tan. Always when you do shift second function, leave the negative out. Can't stress that enough. Very, very, very critical step right here. Normally student will just put the negative and move right along. I think that you got it correct. In situations like this, because we're working towards a distinction, you can't afford to lose even a mark or two. All right, 3.6 said determine the general equation of theta in the following equation without the use of the calculator. Very important. Then they're giving us 5 marks for that. So let's go ahead and scoop those marks. So we're saying 2 sine theta is equals to negative square root of 3. So we're looking for theta. We're going to divide everything by 2 here. Then we should have sine theta is equals to negative square root of 3 all over 2. Right. Remember what I said, whenever you see a negative, guys, whenever you see a negative, always make sure that you take out the negative and then you get the reference angle first. So now we're going to come here, remove the negative. We need to get the reference angle. We're going to say shift second function square root of 3 all over 2. So this one gives us a reference angle of about 60. Great stuff. So now, where is sine negative? Where is sine negative? Sine is negative on 2 quadrants, which is the 3rd quadrant and also the 4th quadrant. So you know, on the 3rd quadrant, you would say theta is equals to 180 plus the reference angle. This is on the 3rd quadrant. So it's going to be 180 plus 60, which gives us an actual angle of 240 K plus, here you must say K 360. Remember, this is a general equation. And then also another one, this is on the what? This is on the 3rd quadrant where it's negative, and then also on the 4th quadrant where it's also negative, is going to be theta is equals to 360 minus the reference angle, which is going to be equals to 360 minus reference angle, which is 60 in this case. Therefore, you're going to be left with an answer of 300. Theta is going to be 300 plus K 360. Okay, most learners skip these parts, guys. Trust me, even in grade 12. So if you can master this now, you have done yourself a favor. In grade 12, you wouldn't have to struggle with this. So now, if it was positive, we're just going to deal with it as a positive and say, where is sine positive? Sine is positive on the 2nd quadrant, right? So I'm going to repeat the diagram that I said is very, very important that you guys need to master. So yeah, it is right here. So you do like this, guys. Even if it means you must immediately, when you get into the exam, before paper 2 even starts, you must just write cast. Okay, this is the magic diagram, guys. This I'm giving you it to your DNA. 180 minus x 2nd quadrant, 180 plus x 3rd quadrant, negative x 360 minus x. Okay, and then we have got those ones of 90 minus anything that has got 90 plus or minus sine and cos must interchange. Okay, but however, the important one is one of cos 90 plus. This one changes into negative sine. With this, guys, you should never struggle. This is this right here. This right here, it's where all your answers are. The rest is algebra, trigonometry, simplification and whatnot. But this is your trigonometry. Whether you are in grade 11 or you are in grade, oh, sorry about that. That's question 4. Whether you are in grade 11 or where, guys, this is your DNA. I call this, oh, excuse me. I call this the DNA. This is the DNA of trigonometry. All your trigonometry is right here. So please, guys, if you haven't subscribed, please subscribe. If you're enjoying the lesson, give this video a like, or leave us a comment, just to encourage me to do more videos for you guys. And I'll see you on the next one where we'll be doing question 4. All right, guys, here is question 4 as we continue with this paper. Thanks for tuning in again. And if you have not watched paper 1, or also you haven't watched from question 1 up until question 4, please make sure that you watch this video until the end. Then you'll be able to click on the link that will take you on the playlist where you will find this whole paper. So now let's continue. It says here, the sketch below are the graphs of f of x and g of x given as follows. And then they said these graphs are drawn between negative 180 and then 90. So this is the period. So therefore here it's 90 and then here it's 180. I hope you guys can see. I tried my best to zoom the sketch, but I think it's visible, right? So let's come here, unless if you're watching from your cell phone, but I think you should. It looks clear to me, but I will speak on the numbers as we move along. My name is Gaston Mapala, right here at Maths with Gaston. If you haven't subscribed, please, I'm asking you to subscribe. That will help us to do more content when it comes to mathematics, right? So 4.1 says determine the values of A, K, and P. So and 4.1, I'm just gonna give you a quick lesson here. At 4.1, when it comes to trigonometry, let's say for an example, you've got a function here, it says y is equals to b sine x. So this one here refers to an amplitude. This measures an amplitude. So an amplitude is a situation where the curve, if it's drawn like that, and here is the axis, you are looking for this. How long does it take for this number here? If it's 1, it's 1. If it's a positive 1 there, it's 1. If it's 2, here you're going to have negative 2, and then here you're going to have 2. And then here you would normally have, let's say, if you have another one like this, just a quick reminder, guys. If you had another one like this, ax, so this one would normally affect the period of the graph. How long does it take for the graph to complete a circle? So how do you measure a period? A period, it means it's starting from here. This is where the period starts and then it ends here. When it completes a full cycle like that, or a full revolution, let me just make it visible, something like that. So this would be your period, starting from here up until here, gives you a complete period. Okay, and then this will be how the graph, if you have got here on the x, if let's say this is like something like this, a, and then you have got an x plus or minus p here. This simply shows shifted to the left or right. So here you are just simply shifting. That was a little bit of theory of things that you need to know, and you also need to know the original graphs of sine, cos, and tan, so that you can know how were they shifted from their original position. So please know the sketch by heart if you have to, and just know where the graph touches 0 and where it touches on the y-intercept and the x-axis of these graphs here, sine x, and then cos x, and then also tan x. Right, this would help you a lot, guys, for you to know this by heart. So please take note. You should know them by heart so that you know what to do. Okay, so now a, we know that we said this b refers to the amplitude. So in this case, the value of a will be the amplitude. So let's just check. From here to there is what is 2, and then from here to there it's also 2, and then on the g of x, which is where is here, g of x is this one, from here to there it's also 2. So therefore this simply means now our amplitude, which refers to the value of a, would be equal to 2 for both graphs. So we know the value of a, and then k in this case refers to the period. How long does it take for it to complete a cycle? Let's start from here. Started from here, and then it goes around up until here. So it took exactly 180. So how was the period affected? So the period here is 180. There's a formula that says period is equals to 360. Is it? Oh yes, period says 360 divided by k. So if they are saying the period here it's 180, so if the period is 180, then what will be k? So this is what it is. Therefore we can come here and cross multiply, guys. K would therefore be equals to 360 divided by 180, which gives us 2. Okay, so k will be 2 here, right? Hope you guys are following. If you're not following, please let me know on the comment section below. So now here we need to find p. So p, guys, you found it in a manner to say how was the graph of g shifted. Okay, so if you see the graph of g, the original graph of course would touch here on 30. It would normally be something like this. Would touch here on 30, then it goes around, something like that. Okay, then it would be like that. So now, as you can see, this graph was shifted to this side. Now it's sitting here on 60 and it goes all the way up there to 2. Okay, So now this simply means now the graph shifted by 30 to the left. So that will be 30 degrees. Okay, that's it. And then let's move on to 4.2. 4.2, what is the period of the function f? I think we already said that the period is going to be 180. I think we did explain the period somewhere there while we were finding the value of the period of f. Yeah, when we were finding the value of k. So the period is 180. Okay, 4.3, what is the range of G? The range of G, I'm going to try to erase here. The range of G refers to the y values of the function. So as you can see here, the maximum value that it touches is this one here, which is 2, and the lowest value that it touches here is this one here. So our range will have to be y greater or equal to -2, and then y less or equal to 2. That should be our range, right? That will be our range for g of x. Okay, that's where we see the function. 4.4 says for which values of x. Yeah, now this is where most learners have a problem here. So now I'm going to try to explain this, but guys, if you don't understand it, I've got videos. Please let me know on the comment section so that I can give you a link to the videos where it shows how to deal with problems of for which values of x is f of x equal to g of x, or for which values of x is f of x less than 0. So I've got a video that solely explains this, but I will explain as we move along here. So 4.1.1, it says for which values of x is f of x equal to g of x. So basically they're asking you on which values of x are these graphs touching each other. So we're going to say on these values, let's see, this value right here, they are touching. So this value right here would be how much? That's 90. This is 60. So let's see. We can say it's in between. We can say, let's estimate it. I think it's gonna be -80, just before 90, because I think here there's gonna be 70 and 80, then 90, right? And then where else are they touching? They are also touching here, which is in between. Let's say 40. So x is equals to 40. They are also touching, and therefore here also they are touching where it is equals to 60. So that's where the two graphs are equal to each other. So I hope you guys understood and you are following, right? So let me remove the other marks here so that we deal with the problem at hand, right? So we're done with that one. So I'm gonna remove these marks here. We already marked where the two graphs are touching each other. Let's move along, move to the next one. Next one, 4.2. For which values of x is f multiplied by f of x multiplied by g of x less than 0? So this one, guys, you can rearrange it and say for which values of f of x, because when it's like this, it's a little bit tedious to work with. So you can change it and say take g of x to the other side and say for which values of x is f of x less or equal to g of x. So now if it's like this, now you are saying for which values of x, am I right? Yes, you're saying for which values of x is f of x less than g of x. So for which values of x on the graph where f of x is below this graph. So let's see, f of x here, it's above. When it gets here at this point, it starts being below, and then it's below, it's below, it's below, it's below, it's below, it's below, up until this point. Okay, so let me see if I'm explaining this properly. Let me see. No, I'm not, because when I take this side, it's gonna be negative. Totally wrong about that. Okay, let's leave it like that. Okay, now there's something when we do this f of x, we normally say above the ocean, above the x-axis, anything above this x-axis is what is referred to as a positive. So everything above, so anything below here, it's what? It's negative, guys. So it's negative, 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 negative. So for you are looking for a situation where the two graphs, they are both at the same time above, and then they are both at the same time below. So now let's have a look at here. If you look at here, the other one is above, the other one is below. So when you multiply the two here, you are going to get what? A negative answer. Right, great stuff. So now that's what you want. You want an answer that's what? Less than 0. So it's going to be between 180. It's between 180 and then this value right here. Okay, this value right here, which we said is what? Is 80. I think so. Yeah, we said is 80 there. Okay, and then where else? And then let's have a look. Hope you guys are following. In this case, let's see. This one, they are both below. So starting from 60. Let's see. Yeah, between negative 60 and 0. They are, the other one is below and the other one is above. Here everything is above, so that scenario wouldn't work. So now it's x when x is greater or equal to negative 180, and then but less or equal to negative 80. And then another one, because there's 2 marks each, and then another one we said between here, which is from 60, x greater or equal to negative 60, and x is less than or equal to 0. So these are the two values thereof. Okay, so I hope you understood, guys, but I know that it's a little bit jiggity, but this is what I'm saying. What I'm saying is, anything, if a graph is above the x-axis, is considered as being positive. When it's below, it's considered as being negative. So here, assume this side here, you are saying you are looking for something that is positive and a negative multiplying each other to give you a negative value. So if you have got a negative and a negative, you're going to get a positive. If you've got a positive and a positive, it will give you a value greater than 0. So now a situation where they've got a positive and a negative is starting from here, going there, and then you skip this side in between, starting from here, going there, and also from 0, going there. So you just have to classify these two situations right there. Okay. So now they are saying 4.4.3, they are saying f of x divided by g of x be undefined. So basically you are looking for a situation where g of x is 0. So for this thing to be undefined, g of x has to be 0. So where is g of x 0? Where is the g of x 0? Where does it have an x value of 0? It has an x value of 0 right here. Right here, when x is equal to negative 60, then this thing will be undefined. Right, great stuff. So now let's come here. 4.5. 4.5 said, what will the equation of h of x be if h of x is given by that? Okay, so 4.5. So let's write first the equation of g of x. G of x can also be rewritten as 2 cos x minus 30. Remember we said p is equals to 30. So now they're saying h of x. So where there is x, we're going to put this. So this is part where there is x. So it's going to be 2 cos. Where there is x, we put that. We're going to put 2x minus 2x plus 30. This is where there is x minus 30. Close bracket. Therefore 2x, and then 30 minus 30 is just gonna be left with 2x. So therefore our new equation will have to be 2 cos 2x. Danko. Then that's how you would deal with questions like this. So questions like this one, guys, just look at the sketch, know how to deal with functions, know the basics of the functions, how is the function moving, know the period, know the amplitude, know the range. Yeah, so if you know these things for parabola, hyperbola, when it comes to trig, they shouldn't be tricky. I know the guys, a lot of guys say trig is tricky, but I think it's, if you learn the basics, you shouldn't have any problem. My name is Gaston Mapala. Let me see you on the next upload. We will be doing question 5 on this paper. See you on the next one. All right, guys. So here is question 5. So I'm thinking we're going to do on this video, let's do question 5 and question 6. So stay tuned. You might as well see question 6 as well, because I think it's proving a theorem, yeah, on question 6. So it would be quite interesting for you guys to see that. Right, so let's see. Question 5 says, in the diagram below, AM is a diameter. The way I teach Euclidean geometry, because a lot of learners found it very difficult, the way I teach Euclidean geometry is that whenever there's a term, it tells us which angles to look for. So they are saying diameter. So the angles that you start thinking of already when they speak of a diameter, guys, if you don't understand what I'm saying, or maybe you've even watched a lesson, one of my lessons on Euclidean geometry, please let me know on the comment section below. I'll send you a link that will take you to the video that has got a lesson. Then you can come back here with full understanding on what is happening here. So now, but I will try to explain as we move along. So diameter starts making us to think about the angle at the center, angle at semicircle. You see, so these are the angles that we start thinking about immediately when they speak of a diameter. We must just know that somehow we're going to have a 90, and the angle at diameter is going to be 180. Angle at the center twice angle at the circumference. Okay. So now with that, and then they said the RPS is a common tangent. Keyword tangent. When they speak of a tangent, you know in grade 11 tangent Tankard theorem. So it means here on this diagram, somehow there must be Tankard theorem somewhere there. And guys, if you still remember Tankard theorem, it says what? You guys know Tankard theorem. For those of you who don't know Tankard theorem, if this is a tangent, Tankard is equals to internal opposite. Right. So now at point P, there's a tangent. So here's point P here. They are saying, so this line is a tangent. This line drawn here is a tangent. And then they said A, PB, and MPN are straight line. So if they speak of straight lines, ne? Now this is what you start thinking about. They didn't say parallel, so please, we're not going to do any parallel. You must think of what? Vertical opposite angles, this one and this one, this one and this one. Angles on the straight line, they give you 180. So every time in Euclidean geometry, they will tell you which angles are there in the diagram. If they don't say anything, they didn't say anything about parallel lines here. So I'm not expecting that when we do this question, we're going to find co-interior and anything that it has to do with alternating angles and stuff like that. So let's go and see if we're going to be correct. Right. So either you dissect the diagram first, or you go to the question, but I would prefer dissecting the diagram, because they said AM is the diameter, so it means here is 180. Somewhere here you've got a center, so this is 180. Angle at the center is what? Is twice angle at the circumference. So which one is at the circumference? Here we've got P1, it's at the circumference, so it's 90 here. Then here it should be what? 90, 70 as sum of angles in a triangle. So this one should give us 20. Great stuff. So if that's 90, say therefore this is also 90 vertical opposite angles. Okay, and then if that's vertical opposite angles, then it means angles on a straight line. I think let's go and answer the question. We will see. They said 5.1 given the size, or give the size of P1. P1 is what? Is 90 degrees. They didn't say a reason, but okay, we'll just give a reason. angle at semicircle. So angle at semicircle. Right, and then 5.2, they said show that BN is the diameter of the smaller circle. So it said show that BN is the diameter of the smaller circle. So therefore, if P4, if P4 is 90, if P4 is 90, so P4 is equals to 90. Reason being, it is equals to P1, which is what our vertical vertical opposite angles. All right, so therefore if that's the case, then therefore it means it's the inverse. Therefore I'm writing on everywhere now. Therefore NB should be a diameter. NB is a diameter. NB is a diameter. Yes, it's a diameter because if this is 90, therefore this is 180. So angle at the center is twice angle. And if that's the case, therefore NB would have to be a diameter. Right. 5.3, they said if M1 is equal to 70. Okay, there it is on the diagram. Calculate the size. Calculate with the reason the size of the following angles. Angle A is equals to 20. Reason being sum of angles in sum of angles in triangle. Which triangle is this one? Triangle AMP. Okay, and then they said look, P6 is equal to, now P6 is this angle here sitting there. Now let's look. P6, it's this one here. Let's see, P6, this angle right here. Okay, so P6, if they said what? They said this is a tangent, RPN is a tangent. So this is P6. So P6 here, it should be equal to internal opposite angle. So internal opposite angle is this one here, which is what? 70. Right, which is 70. Is 70. Reason being what? Tankard theorem. It's equal to 70 because of what? Tankard theorem. Which one? Because which one is the tangent? RS. P is a tangent. Okay, so therefore B, they were looking for B now. They want us to find B. So if this is what, then therefore this is also tankard. So S2 is equals to 20. So if S2 is equals to 20, therefore even B is equals to 20. Okay, I think so. Let's just have a look at this one quickly. Just have a look at this one quickly. Yes. Right, so if this is equals to 20 because of this 20 there, okay, let's come and write it here. S is equal to A, reason being what? Tankard theorem. Okay, so therefore, so this is 5.2.3. So therefore now this is will also be equals to 20. So if you look at this triangle here, there's the 20 there. So this 20 here, it's also equal to that. Okay, it's also equals to this angle here is equals to that because of what? Tankard theorem. So therefore B is equal to S2. This is S2. No, not S2, man. P2. What am I saying? Not S2, P2. Excuse me for that. This is P2, P2. Right, great stuff. So B is also equals to P2, reason being what? Tankard theorem. On which triangle? On triangle. This is what? Tankard theorem. On triangle A, on triangle what? B and P. All right. I think it's clear enough. You guys are following. I know that you guys, the only theorem that you need to master in grade 11, now I'm plugging you now, it's Tankard theorem. There is no way, I've never seen a paper in grade 11 which doesn't have Tankard theorem. So please guys, pay attention, make sure that you follow, and then you master this Tankard theorem. It is always going to be there. Now I think let's move on to question 6, because it's just one question with 5 marks. Yes, question 6 here, they said the figure below O is the center. Okay, we like that. Told us the center, so it means we're gonna be dealing with twice angle at the circumference something. And then they said now of the circle, and then PRQ is a cyclic quad, so it means you can draw a circle around it. So now they are saying we need to prove that this angle here, opposite angles of a cyclic quad, they are equal to 180. So they want us to prove that these two angles here, they are equal to 180 when we add them together. Best thing to do here in this case, guys, you must just divide your diagram, divide it, right? So you're going to have O this side and then O that side, right? So now you're gonna, let's just mark them O1 and then O2 for the sake of understanding, of course, and for the sake of proving this theorem. Should you draw this while you are answering? Yes, of course you must draw it so that we see what you're talking about. But however, if you can prove it without drawing, so I think you won't be able to do, you need to construct the two so that we can be able to see that. So now it says here O2 angle at the center is going to be twice angle at the circumference. So now O2, let me see, O2 it's equal to twice R. Okay, therefore O1 is equals to twice T. Angle at the center is twice angle at the circumference. So with that, okay, that's our reason here. Angle at center equals to twice angle at circumference. Same reason here as well, guys. All right, so now you would say, when you come here, you would say O1 plus O2 is equals to 360. Okay, so now you will take where there's O1, you substitute. Where there's O1, you will substitute here. Where there's O1 is equals to T as well. Okay, and then where there's O2, you would put 2R is equals to 360. Therefore, you take out 2 as a common factor on this side. After doing that, okay, we didn't give a reason there. Okay, I think so we'll remove the 2 as a common factor. Sorry about that, guys. I'm thinking about something else that I forgot. Here we didn't give a reason. These are angles at a point. Angles at a point all around 360, they give us 360. Ne? So divide by 2, divide by 2. So now you have successfully proven that angle T plus angle R is equals to 180. With that said, then you get your full 5 marks. I am Gaston Opara. Let me see you on the next upload, guys. We will be doing question 7. If you haven't subscribed, please subscribe to our channel. We solely focus on pure mathematics content, and I enjoy doing this thing, making sure that everybody learns from it, and then we get a distinction and everybody is happy. Let me see you on the next one.